afternoon, everybody. Welcome to today's TDAG meeting. My name is Emma Ferranti, and along with Sue James, we organise meetings of the Trees Design and Action Group, which is a network and a forum that brings people and organisations together to support the role of urban trees through better collaboration in the planning, design, construction and management and maintenance of our urban places. So evidence-based information is really important to us. That's why we brought you all here today. Collaboration is really important to us, and so we are very grateful to our partners, the Chartered Institution of Highways and Transportation, and the Institution of Highway Engineers for partnering with us on this event. So very shortly, I'll hand over to Jim Smith, who is our chair for the day. Jim has been an urban forester for over 35 years. He first worked for the Forestry Commission after leaving school and was an arborist in the Royal Parks in the early 80s. He's a chartered member of the Institute of Chartered Foresters and has twice been chair of the London Tree Officers Association, being involved in the production of many national and regional guidance documents involving trees. Jim is currently an urban forestry advisor to the Forestry Commission. So without any further ado, over to you, Jim. Thank you.
Jim, you're muted.
Right, thank you very much, Emma. It's a pleasure to be here and welcome everyone who's just joined. Here to have another really good TDAG seminar looking at trees in the underground space. And it's something that's really, I think, really important. And I think if anything, it's more important now than it's ever been, because we're now beginning to see the events in Southern Europe in terms of climate change and the wildfires that have been going on, and the heat temperatures that have been coming. Everyone was expecting that to kick in at in the 2050s to 2080s, but it seems now that this is happening much more in an accelerated fashion. And we as a sort of a selection and a group of professionals, it's more important than ever that we actually rise to that challenge, and we're in a position to actually affect real change in that regard. So one of the things that TDAG is well known for, the mantra, is that trees are critical infrastructure. And one of those things that TDAG has been pushing for quite some long time is that trees have parity in built infrastructure. I'm pleased to say that the National Planning Policy Framework highlighted that by suggesting that developers work more closely with highway officers and tree officers in the future to get better outcomes for trees in our highway situations, but not just highways, but in planning and development situations altogether. So we've got some excellent speakers for you today. We're going to look at trees in the urban landscape and how we can integrate them better, particularly in regard to the underground space. Now, when you think about it, 1/5 of a tree, there's a 1 to 5 1 to 5 root to shoot ratio. So 1/5 of the tree is actually hidden underground, and a lot of people really don't appreciate the fact that the biomass of the tree, 1/5, 20% of the tree's biomass is underground. It's almost as if although all the canopy of the tree and the upper portions of the tree deliver those ecosystem services by magic, but they're reliant, as everyone knows, on that underground space as well. Roots have every right to exist in that underground space. I would argue more so, in fact, because they've been around for millions of years and have squatters' rights almost. So if there's one thing that I'd like you to take away from, as well as the messages from the speakers you'll hear later on this afternoon, one thing I'd like you to take away is that we should consider trees to be the 5th utility after gas, water, electric and telecom. And my own personal view is that we should actually be moving towards making them the 6th statutory undertaker because of what they deliver for us in terms of climate adaptation, resilience and all the health and well-being benefits that we have. So enough from me. I'm going to now hand over to Hen. Hen, if I could ask you to introduce yourself, that'd be great. Thank you very much.
Yeah, hi, thanks, Jim. I've turned my camera off because I've been having a few connectivity issues. So could everybody hear me okay?
Absolutely, Hannah.
Yeah. Can I get some thumbs up or something? Otherwise, I'll just admit to
Loud and clear.
Yes, Hen, we can hear you.
Yep. Okay, that's brilliant. Thank you. Right, I'm going to try and share my screen. If this worked well when we practiced, but bear with me. Okay, so hopefully you're seeing a screen. Is the title of my speech. I was given,
that's up.
It's quite catchy, you can see. Okay, so I'm not going to waste your time. I'm not going to hang around for too long talking about this. It's quite a quick presentation. I'm aware that some of my fellow presenters probably need a little bit more time, so I'm not making any apologies for being closer to 10 minutes than 15. I'm not going to give you any answers. I'm going to try and explain to you what we as highway engineers struggle with. I've put here how to be sure the right tree is planted in the right place, in the right way for its life. And that is really the key to what we are trying to achieve as highway engineers delivering street trees. So I kind of call this the stresses, which is a nice, simple way of looking at it. The 4 things that we need to be aware of looking at: the space, the species, the soil, and the support. And I'm just going to go through each one of these 4 fairly quickly, just give you a bit of an overview on what we have and some of the challenges that we have. So the first one, space. Now this is a live planning application. It may have just been approved. It's not historic, it's not old. This is what we're seeing coming through planning right now at the moment. I genuinely can't remember where it's from, and it really, really doesn't matter. I'm probably going to get shot by developers for saying this, but they do all look much the same. So here's your street trees. I don't know if you can see my cursor, but they are delivering as per the NPPF. Street trees, tree-lined streets. But I just want to zoom in to one of them. It could be any of them. I'm going to zoom into one down here. And you'll see that what we're being offered is a tree, a generic green blob, into a verge between an adopted highway footway and adopted highway carriageway. So that's on the surface, but underground, this is what you've really got. So you've got your carriageway here. This is concrete curb backing, sub-basin capping. It will vary depending on the bearing strength of your soil. Then on the other side, you've got the footway. You've got the concrete backing for the edge. Now, I don't know, some of you may not be able to see, but I've put a very faint yellow line here. This is just to make some of you aware that one of the options that's being investigated to try and prevent the foot whacking that we're seeing a lot come through from the dry summer last year is to increase the space of the footway. So this just gives you an idea of how much space there is. So moving on to species, this is the same tree. This is the landscape drawing. So these have been drawn up by a landscape architect and submitted as part of the planning application. From this, we can see that they're proposing 7 Magnolia corvus, all in a row along there. No, I'm not an arboriculturalist. A lot of highway engineers, maybe I don't even like gardening very much. We don't have the expertise to know what that is. So I Google it. The RHS guide is generally my go-to. From that, I can see that this tree that's being proposed as acceptable in that space, if it thrives to maturity, which is what we want, will have an 8 to 12 metre height with a 4 to 8 metre spread. Okay. I'll leave you to think about that. And this is just something that I found on a quick Google, which I thought was quite illustrative. It's a magnolia root system, different variety of magnolia, I suspect. But a very quick measure gives you a roots are about, the span of the roots is about 10 times the trunk. So if we assume this trunk to have a diameter of about a foot, 300 mil, it's probably bigger than that, but keep the math simple, you're looking at 3 meters for the roots to spread. Now, let me just remind you of what space we're actually working with there. So I'll move on to my third soil. And this again is just an image that I found online, but it's quite good at just showing you what happens on a construction site. So I'm guessing this is some kind of drainage pipe. So this is probably where the footway is going to go. This side of the curb, you've got the carriageway. So this is going to be the verge, which is where you're proposing putting that tree in. I don't know if that's suitable soil. I suspect not. It's got bits of concrete in, there'll be no topsoil, it'll have been dragged from wherever. So when I talk about soil as my third S, I'm also talking about really the tree planting system, which, you know, hopefully is not just going to be the bare construction soil. And this again is just a very quick Google search of tree pits, tree planting methods, and there is so much choice. I mean, this is kind of what we're all familiar with: dig a hole, shove a tree in. But there is so many other options out there. There's different kinds of tree crates. I think this might be a Stockholm soil. I'm not entirely sure what this is, but this has got tiny root system. We've got linear root guard, which I know Kid Saker did a presentation on last time. It tends to be my go-to because I understand it. But yeah, this is just a very, very, very brief example of a tiny proportion of the systems that are out there that we could be offered as highway engineers, with someone telling us to accept this. Do you think it's appropriate? So moving on to my last S, I told you this is going to be quick. Support. So I encompass that. It's just so the initial support. You've got the stakes, ground anchors, drills, watering or not watering. So we need to understand what that species needs. That will depend on the weather, it will depend on the location. If it's windy, it will depend on the age of the tree. And also, if by some miracle we manage to get the space right, the species right, the soil right, and the initial support right, and that tree does thrive and grow to maturity, we've then also got to consider the ongoing long-term maintenance support of the tree. Now, I mean, these are just various images. Some of my own photographs. Actually, I think most of them are my own photographs. So these normal things. You will notice I haven't mentioned relief on footways for the very simple reason, as everybody knows it's a problem. It's very boring to talk about it anymore. I'm not saying it doesn't exist. It does. We all know it exists. But these are other things that perhaps don't immediately spring to mind when you're talking about some of the damage that trees can do, or some of the maintenance that trees need when they thrive. Both on the behalf of the tree, you know, we've got to remove this stake when the tree no longer needs it. That's something we've got to understand. Same thing is happening here. The tree's growing into the guard. It's sharp grill here. Here you've got a tree that just didn't get the initial maintenance. It's thriving quite nicely, which is lovely, but it's difficult to walk past. I mean, this one, well, where to start? Trees overgrowing road signs, and actually trees overgrowing street lights. Now, this is probably the hidden part of it. The first three parts that I spoke about, you're all probably very aware. Yes, get the planting right, get it started, get it watered properly. But this is what we as a highways authority, this is our legacy, this is what we're left with for 20, 30, 40 or more years. And it comes at a cost. It comes at a massive cost. And that leads me nicely onto commuted sums. Now, I'm not going to linger on commuted sums. It's a topic all on its own. It's a debate all on its own. But I did want to mention it here because it is pertinent, it is relevant. And this is just, again, a quick Google search. These are a few authorities. I don't know where they are. I can't remember. It doesn't matter. These publish their commuted sums and they vary widely. It's something that I know Sue is very keen on, to try national guidance on commuted sums, and it is really needed. So that is me done. I did say it would be quick. So these are the things that we need to understand as highway engineers. Is there enough space? The space we start with, that's not changeable. Species, is the species right for the space? Soil, is it the right tree planting method? And support, what support does it need long and short term? So thank you very much for listening.
Well, thank you very much, and that was brilliant. And I must say, I can't remember the last time I saw a magnolia as a street tree, so I'm with you on that one. That's great. Now I'm going to just go over to Sue to say, Sue, I can't see the chat. So are there any sort of really urgent questions in the chat that we can ask Sue to Hen to answer?
No, so there are a couple of things. Tim Arkle made a very good point that tree growth and max size in urban context is likely to be reduced from the RHS sort of guidance. So it might be worth referencing what's more likely to be. I don't know, if, Tim, if you've got anything to add to that. No. The other thing that came up, well, I just made a note of it myself. Hen, you mentioned that you're offered different options of how to plant street trees or trees. And which one do you think is the best way to do it? Is that, did I understand you properly?
It kind of, what happens with adoptions, which is, I was, you know, largely looking at this for adoptions, when it comes to retrofitting existing highways, it's different problem. It's the same problem, but a different aspect. The highway authority needs to make that decision. When it's a tree that we're being offered, a road with a street tree that we're being offered for adoption, we can be offered different planting methods. The Gloucestershire specification is a concrete tree ring, which I really don't like. So I do tend to listen to people that are offering me something else. And yes, it's up to us as a highways authority to agree that planting method if that's suitable. And the point I was trying to make is we just don't have that knowledge at the moment.
That's what I was thinking. So there's a potential for the performance gap there.
Very much so.
You're being asked to make decisions. The other thing, Jim, which you can answer, is at the National Tree Officers Conference, you mentioned this supplementary technical guidance that we're working on with civic.
Yes, yeah, that's still in preparation. You may know that the manual for streets has been paused while they're looking at some of the comments, the consultation threw up. And so what we've done is, in terms of preparation for that guidance, which is a revision of the Forestry Commission's Operations Note 151, we're still preparing it, and we're waiting to see the outcome of the Manual for Streets revision as well. So we want to tailor, because we've got an agreement with the Department for Transport that that Operations Note 51 will be supplementary guidance, and it'll look at, it won't just look at engineering solutions, but it'll be looking at planting trees in the highway as well. So that's still in preparation, and we'll through TDAG let you know more about that as we get closer to its publication.
There's some interesting comments in the chat, but I will take all the chat at the end and analyze
okay, we'll come back
to
go
out to everybody. So
you'll come back to that at the end with a sort of general question and answer session, right?
Yeah.
So slightly ahead of time, which is always good, because that leaves us more time for discussion at the end. I'm going to hand over now to Bjorn Embrem. Bjorn, if I could ask you to introduce yourself, that'd be great. Thank you.
Okay. So I'm Bjorn Embrem. I have been working in Stockholm with gardening business for over 40 years. Garden worker and worked in central parts of Stockholm for 10 years, planting trees, annuals, shrubs and everything, maintenance in the absolute central part of Stockholm. Then I was a supervisor and entrepreneur for 10 years, and were maintaining the annual plantings in the central part of Stockholm, and I had arborist groups and everything you can think of in maintaining a city, including snow, taking away snow from the streets and everything. So it has been a good thing to have been working as a gardener and a supervisor before I became a tree officer in Stockholm. So I had a good, I knew about the problems to get plants to survive inside the city, and what you need to understand about the city if you want something to work, especially if you want to start to build plant beds in the city. And it's after I went to University of Hanover and saw a presentation after they had made research over 10 years in Hanover, trying to find out which were the best material to use for urban trees below hard surfaces to get the trees to survive. I tried to use that knowledge in Stockholm and to create something that could get the trees in Stockholm to survive, because at that time, I realized that more than 30% of the trees inside the central part of Stockholm were dying, getting smaller every year, and was really dying away for us. So the problem was, as you know about, I mean, the sealed surfaces and the compacted materials that are the problems, and the lack of oxygen and water in the ground. And if you should make a plant bed in an urban environment like Stockholm, you have to have a strong construction that can support a lot of loads on top of it, and at the same time, so you can give the plants what the plants want. And they must be possible for them to cooperate with all the infrastructures that you have in the city. And it must be easy to build, and it must be easy to excavate in it, because there are always excavation done in the city. It's repeatedly over the years, it's going to be excavation. And so it must be really easy to recreate the plant bed if you have done an excavation. And if you want to make new plant beds, it must be a simple construction, because the more complicated constructions you have, the bigger chance you have to fail with your construction. And people don't want to have complicated things. And if you have overcomplicated construction, they will be forgotten. After 5-6 years, people disappear, no one remember what was done in the ground. So if you have a construction that everyone can understand how it works, it's the best way. I've been trying to explain what we have been doing in Stockholm for more than 20 years now. And it has been a question of how can you teach people and learn other people to understand what we are doing. So I tried to find out what is the most important things you have to know about the plant bed in the urban environment if you want to have a good plant bed that will survive for a long time. So this is 10 different things you have to think about and to ask yourself, how do I get them to work? So this is the question you have to ask yourself. I'm going to make this plant bed in urban environment, and I must have answers to all these questions. And I have to understand all these different factors if I want to have success in an urban plant bed. And as I was fortunate to visit the University of Hannover, where they found out that the best material you could use in an urban environment to get a good plant bed and to get the best to get the root system to grow the best, expand in the best way is a stone material, in sorted stone material in short sizes. It's almost the same size. Then you get the most voids between the stone. So you get extremely good porosity if you use this. And we call it macadam in Sweden. I don't know what you call it, but it's crushed stone and it's shifted. And you can get up to 40% of porosity in this stone material. And the biggest size stones we use below the streets and sidewalks, and the smallest we use in open plantation for shrubs and perennials and trees. So for example, the 2 to 6 millimeter is what we plant all our perennials and shrubs and trees in open areas. And then we mix it with some sort of compost. You can use different kinds. And we also use biochar. And mostly we use the same amount of compost as biochar in the mixture. And if it's below ground, below hard surface, it's 15% of compost and biochar. And if it's open space, open ground, it's 25% of compost and biochar. So this is how it looks on the drawing, a popular drawing from the handbook of Stockholm, where we show how we are building our plant beds in Stockholm. And it's a very big stone material in the bottom, and that are put down and then compacted and then flushed down this combination with biochar and compost between the stones, so you don't gonna get any compaction of this material that you flush down. And then you can do it in different layers. You do it in different layers of 30 centimeters, compact the stone and flush down, compact the stone and flush down. And then we have a aeration layer, an infiltration layer on top of that, so the plant bed can breathe and get enough with oxygen, and you can also infiltrate the rainwater from the surface, the hard surfaces. So this was the first method we used, and it was accepted because it was what we call macadam in the bottom, and it was known as a road building material. So everyone that was building roads were familiar with this kind of material and how it worked. So that's why we got approval of making this the first time, because they could understand the material. But still we couldn't change the surface. So we had to come up with the idea of this well that we could infiltrate storm water and get the gas exchange to work, to get enough with oxygen to the ground. So this we used for 10-15 years. Then we came up with the idea to make a simpler and faster construction. So we started to use a smaller size of stone. In this case is 36 to 63 millimeters stones, and is pre-mixed with 15% biochar and compost. So it's easy to understand that this is going to work so much faster in the construction period. Otherwise, it's the same thinking that you use the well for the infiltrate water and get the gas exchange to work. So gas exchange, I always say, is the first thing you have to have the solution for, because if you don't have a working gas exchange, you won't get anything to work. You can go back to this and read it afterwards, because there is no time for me to explain everything about why gas exchange is important. But you have to have oxygen in the ground. It's important for all the living organism in the ground. If you want to have a healthy plant bed, you must have a good working gas exchange. And we make it with our wells or open surfaces. So water, it's hard to say which is most important, but if you don't have oxygen, you can't breathe. So that's why I put it at first. But of course, water is the second most important thing. And you have to know, where do you get the water? How can you infiltrate the water? And how much water can you get? And of course, it's a fantastic for a city if you have problems with under-dimensioned sewage system and things, if you can take away a lot of water from the city in this way. And of course, you should use it as close to the where you get the water from. So use the water locally. And the same thing, we use the same wells to collect water in different ways as we use for the gas exchange. So they have the same function, or the same solution to get water as to get the gas exchange to work. A structure, of course, you must have some structure. I mean, we plant Telias, we plant quercus, and we plant a lot of trees that are going to be several hundred years old. And of course, you want to have a structure that will stay for hundreds of years if you plant trees. You can't depend on something that won't hold for less than 100 years. So find your way of building a structure. And in Stockholm, we use stone as it's in the same way as it looks in the forest around Stockholm. It's the old gravel ridges, eskers, I think you call it in England, from the Ice Age. So they have been staying there for at least 12 to 15,000 years, and the trees are happily growing in these gravel ridges all around Sweden. And there's a lot of them. And it's the same in mountain areas. You have crushed stones where trees are happily growing, and this support the trees extremely good, and it's a good gas exchange, and it's easy for the root system to penetrate this kind of stone material. So we are, depending on where we are making our plant beds, we are using different kinds of the behavioral loads. They have the bigger stones, you could say. And if you want to work with your hands in it, open this plantation, then it's a smaller size, 2 to 6 millimeter, maximum 12 millimeters. Water storage capacity, we use compost, and we use biochar. Biochar is fantastic if you want to have a good water storage capacity. And if you want to increase, you use more biochar or compost. But biochar is the one that gives the best water storage capacity. And biochar, I don't know if you know about biochar. It's organic carbon, and it has extremely good qualities in different ways. And that's a whole long story that I could talk for an hour about biochar, but you can read more about it by yourself. The compost could be it's so varied. You can add really decomposed compost, or you can have fresh organic material. And we have tried a lot of them. We haven't seen so much different between the compost that we have been using. Of course, if it's a lot of easy to get nutrients, you can get much faster establishment and so on. And that's basic knowledge about how plants react to different kind of nutrients. Of course, the situation in the city is also of important, what you have in the ground. It can be concrete, or it can be soil in some compacted way or something. Same with the nutrient storage capacity. How we have solved that is using biochar. And it is amazing to see how much nutrients biochar can hold and share with the plants if they want it. And the same, the compost is also a source of that can hold a lot of nutrients, of course. And what's happening in the ground when you use this mixture of stone and compost and biochar, you support all life in the ground, and you get the circulation and the increase of organic material, because the life is so happy in the ground. So it is reborn and dies and reborn, and the trees or the plants are putting down solar energy in the ground. So it will increase all the time if you have this open material that all the organisms are happy to survive. And the same nutrients, it can be nutrients in the surrounding material, of course, so it depends on what's around your plant bed that you're building. If you can get something for free from the ground below or on the sides of your plant bed. And as I've talked about before, nutrients depends on how much nutrients you want. If you're where you're building your plant bed, or is it a sensitive area with protected watersheds or something like that, you have to have less nutrients, of course. But if you're in a king's garden in the middle of a city, you want to have annual plants with a lot of fertilizer that will give fast growth and healthy plants, then you have to put more, of course, of nutrients in it. But we use different kinds of compost to get hold of nutrients. And of course, if you have this good environment in the ground, and especially you need oxygen for the mycorrhizae to survive and can support the plants too. And of course, the biochar is one of the solution for us when we're using so much stones. We can have the biochar instead of sand and clay and everything, and they will hold the nutrients, and they will leave it to the plants and to the mycorrhiza when there is need for it. And plants, of course, you have to choose the plants for the place where the plant bed is and how the situation is below ground and above ground. I mean, if you have space up, and if you have a space in the ground, you can choose bigger trees, and depending on how much water you get hold of, you can choose different trees. And if you have waterlogged condition, a lot of water, high water levels in the ground, choose trees that love that kind of situation. And the opposite, if you have dry situation, choose trees that can take that. And space, of course. Space is important above ground and below ground, because if it's limited space, even if you get enough with water, nutrients, everything, you don't. If the plants can produce a bigger root system, they can't grow as they could if the space is limited. So it's better to connect as many plant beds as possible. Then you will get better results for your plants. So that's why we try to always, if we have a block in a city, we connect all the plant beds together, so that if there is a water in one end of the plant bed, the trees at the other end can send out their root system to collect the water. So that's why when we build like this, we always get this uniform development of the plants. The trees looks exactly the same. Of course, there can be some sometimes the way some trees is hurt in some way or poisoned and something like that. But normally, if everything is right, the trees looks exactly the same along the streets, and that's fantastic to see. Protection, of course, you have to protect your trees in some ways, and you have to think about how you do that. It can be above ground and it can be below ground also. And this is how we plant. We use these kind of concrete boxes in Stockholm to plant trees inside that, but they're open so that the root system can develop out in the stone material. And it is easy to replant a tree if it's hit by a car or something and broken in some way. You just to lift it up and put it down in a new one, and you don't destroy the surrounding surface material. But one of the most important thing is to how do you have control that the entrepreneurs that are building your plant beds are doing the right thing. You have to know what they're doing, and you have to control it in some way. You can't just trust an entrepreneur to do it right. You have to have control in some way. Otherwise, it can be totally waste money when you make plant beds. And we have had the extremely hard control in Stockholm, where I have worked, and it has worked extremely well, both in the where we build these plant beds and afterwards for the maintenance and the so we follow the contractors all the time. We have a consultant out in the streets for the 3 first years, so we see that they water as they should and do everything that's in the contract. So if you have any doubt, I can promise you that you can get anything of the plants to grow in this kind of mixture. And it was so fun to get the first carrots in my garden when I used the same material there to see if it was possible. And if you want to get inspired, you can see, look into different organizations that's working with alpine plants, because they have the same problems with plants. They have to have a good aeration and no standing water, and that's the same problem as we have in urban environments, because they're so sealed surface and so hard compacted material, and that's what limits the trees to develop in cities. Yep.
Okay, I think, are you finished, Bjorn?
Yes.
I think that was an excellent and comprehensive look at what you need to do to get better establishment of your trees in urban areas and to have better outcomes for the roots. So thank you very much. That was excellent. Sue, have you got any questions, immediate questions for Bjorn?
So immediate question, just one from Chris Hodgson. Have permeable surfaces been used in Stockholm to allow the water and gas exchange?
Yeah, but there has been such bad experience from it, because we are using so much gravel in the winter time, sand and gravel, so it's get this finely material after the winter that it will immediately seal all these open materials. So it just stays open for 1 or 2 seasons, 2 years, and then it's destroyed. And I have tried to wake them clean and things like that, but it doesn't work, sadly.
Those were the immediate questions. There's an awful lot going on in the chat, and I'm sure there are some things that you could probably answer Bjorn directly.
Yeah.
So I won't bother people with that now. We can bring some of it up in our general discussion.
Okay, shall we move on then, Sue? Because we're bang on time, so that's good. Okay, so I think what I'll do is I'll just hand over to Martin Gammy. Martin, if you could introduce yourself, please.
I just share my screen. Good afternoon, everybody. Hopefully everybody can see that. My name is Martin Gammy. I'm an arboricultural consultant and director of Consulting with Trees Limited. My background is in forestry, landscape design and construction, and primarily in arboriculture. And Consulting with Trees offers a broad range of arboricultural services and specializes in in providing compatible growing systems within the urban realm for trees in all sorts of scenarios, but basically in hard surface situations. And what we're going to do today is look at a few of the options that are open to you. You've heard about some of them already, and I'm hopefully going to run through why we need these different systems and how they might be most applicable. And primarily the fact that we've got a palette of options that we can use, and why use one if two is more appropriate. So just going to flick through the options that are available to you. But initially I thought we ought to start with why we need to consider these options in the first place. And I thought this, well, apart from the fact that I really like this sculpture, I thought it summarizes or brings home the fact that we really need to understand the below ground environment and what tree roots need, how they function, and what they need to survive and succeed in the built environment, as they would as if they were in the soft landscape natural environment. So essentially, this is what we're looking for. I would hope that we want a mature tree that's healthy and vigorous, that is compatible in its landscape and capable of sustaining that health and vigor in longevity. Now, some might argue that the natural environment for that tree would be in a woodland, but essentially this is more realistic of what we're trying to achieve, I think, for our urban trees with extensive canopy cover that delivers all the benefits we're already aware of. Now, the reason for the success of the tree is perhaps that the space around it offers a large area of permeable surfacing that enables the exchange of gas, the access of water and nutrients, and the ontake of organic matter to give us the nutrition that we need, in addition to the oxygen exchange, etc., that's needed to create what we would refer to as topsoil. And for the purpose of this presentation, I'm going to refer to as growing medium. So the objective then is to replicate the soft landscape conditions in the urban realm. And the key ingredients, as Bjorn has already identified, are water, oxygen, and nutrients, and we'll look at those in a bit more detail. But what we need to bear in mind as we run through the different scenarios is that we need the growing medium not only to provide those, but be able to sustain those key ingredients. And this is the harsh reality of what we're faced with, and the image shows the extremes of the above ground urban environment that we expect our trees to survive in, and what we're suggesting is that the below ground environment is equally, if not more, challenging than what we're seeing there. So in order to consider what provisions we might make, I'm suggesting that we look at 3 growing zones rather than referencing a tree pit. I'm suggesting that we need to consider 3 zones where the provisions that we need to consider will vary. So the zone 1 is the planting pit, typically approximately just over 2 meters square. Zone 2 is what we're terming the establishment zone. This is where the tree will initially ingress the area immediately around it in order to establish in that landscape. And then zone 3 is what we're terming maturity zone, provision for maturity, design of the below ground environment to deliver integrated infrastructure and compatible longevity. And we could say that that is in excess of 40 square meters, and essentially, as Bjorn was saying, it could extend to the general urban environment. So if we look at those in a bit more detail, Zone 1 is essentially a hole in the ground large enough to plant a standard to extra heavy standard tree and provide a small amount of good quality growing medium, and is usually capped with a permeable surface such as a metal grill. So Zone 1, I suppose, is what you would, the provision you would make if you were planting in a soft landscape setting. The planting pit would usually incorporate irrigation pipes, which acts as aeration and irrigation pipe, hopefully. A simple pipe wrapped around the root ball of the tree. Unfortunately, all too frequently, this is the maximum provision that is made for street trees or trees planted in the hard surfacing. The result being a limited chance of survival, a low chance of healthy establishment, and a poor chance of reaching maturity. Combine that with an unnecessarily high chance for negative impact to other infrastructure. So what we're saying is that there's a massive need to ensure that provision is made at the design stage. When you make the decision to plant a tree, we need to look at these three zones before we finalize that design. Zone 2, I think, is an area where over the last decade or so we've seen an increased provision to enable tree establishment. And this is where the majority of recent product and technique innovation has been focused. The key principles in making extra provision are to provide a load-bearing substructure to hard surfacing, and that this substructure can accommodate uncompacted growing medium, which contains the key ingredients we've already looked at. The main challenges, I guess, are limited available space, other demands on that space, loading to which the surface will be subject, and of course, cost of the systems we're employing. And what I would also say is that obviously, whilst my diagram is fairly it's formal and square, what we're looking at is very variable shapes and sizes that we need to utilize, and these will vary for every site, and there's a need for each design to incorporate or to accommodate the site needs and to be bespoke to that site. So Zone 3, and as I said, this is the provision for maturity. And this is the most challenging of all, as it requires a holistic change in the mindset to the way we design and manage the subterranean urban landscape. And I think we're seeing these sorts of changes now in terms of our house building, the way we heat and insulate our homes, the recognition that we can't carry on as we have done for years, given the climate change and issues that we're facing. And it's the same principles that we're applying here to designing trees into the urban realm. I think we've, Jim said that essentially your urban trees are another utility and an integral element of urban infrastructure. So when we're looking at the options and the potential sites for trees, I think the key areas that we can focus on are new build. That's the easiest. We've got a blank canvas. maximum opportunity. But where there's opportunity for where there's regeneration projects or restoration projects in our towns and cities, these are opportunities that we should be at the forefront of and having our say in from the earliest possible stage, so that we can get the trees with the right provision in the right place. And then we've also demonstrated in the past that engaging with large infrastructure installation or improvement projects and getting green infrastructure in on the back of grey and blue infrastructure projects can not only be effective, but can be cost effective and beneficial to all parties concerned. Okay, so looking at the palette of design options, then I've just put a few images up here to refer to so that we can consider the options that are open to us when we're looking to make that additional provision to ensure that our tree planting schemes are effective, that the trees established and are reach their maturity so that they deliver the objectives of putting them in the ground. So the four main systems I've got up there, if you go from left to right, we've got the crating system. That's in that image is the deep root silver cell. Now, other crating systems are available, but as you'll hear from Steve in a moment, the silver cell has probably been around the longest, and other systems are probably based on a similar template. The central image there, top center, is the permavoid or arbor raft, now supplied by Polypipe. This creates a cellular void system which enables oxygen and aeration in a layer. It replaces the sub-base for paving and surfacing, but it creates a void beneath your paving, enabling aeration, irrigation, stormwater management. Top right, we have the tree box, which again is a permavoid product or infragreen product. This is really another crating system that uses concrete support system and therefore can be utilized for heavy loads such as HGV vehicles, etc. Again, depending on the site and the loads to which the surface will be subject to, will determine which of these systems you might adopt. You can see around the walls of the area there, excuse me, that the arbor raft or permavoid is being used to create the edges of the crating system, and this again assists with stormwater management, irrigation and aeration. Bottom left is an image from Stockholm, and Bjorn has told us all about the pros and cons of his skeletal soil, and as you can see there, it enables using it as a construction material, a sub-base material that is adoptable across the full breadth of the hard surfacing area. So in this case, the pavement, the area beneath the pavement is all essentially potential growing rooting volume. So it's very flexible, it's very adaptive. And there's the central picture at the bottom there is again showing the tree box that the trees are planted in, as Bjorn showed us. bottom right is a cellular confinement system, and these are often used to create temporary access, but can also be a sub base for a permanent hard surfacing, such as car parks or domestic driveways and things like that, or pavements. It's very similar in principle to the arbor raft, although in this case the voids are filled with a clean aggregate, and it is a load spreading concept that usually enables a permeability to allow water to drain through the surface and through to the growing medium below. So some of these systems, and I think we shouldn't always think that we're looking to plant new trees, but some of these systems can be adapted to improve or sustain existing tree rooting areas and accommodate new development or surfacing where that's within the rooting area of the tree. So both the two pictures you can see there, the arbor raft and the CCS, are immediately adjacent to large mature trees. So I think we need to, whatever we're doing in terms of tree management and construction in the urban realm, we need to question when and where these different options might be useful for us to consider. Now, in terms of pros and cons, I guess if you look at the crating system, this will accommodate large volumes of uncompacted growing medium in fairly close proximity to the tree and large volumes relative to the area that it's accommodating. So there are benefits to that, and it's proven very, very successful in establishing trees of significant size in hard surface areas. Perhaps some of the downsides are that it's not that flexible in terms of the spaces it can be put into. You can see that the format is quite rigid there. Obviously costs are always a consideration. But perhaps if we're looking at cost prohibitive sites, you could perhaps use a combination of minimum area of crating to give that tree the establishment zone that it requires to get it established in the site, and then extend beyond that with something like the Stockholm skeletal soil in the rest of the paved area, or a significant amount of the paved area around the crates, and thereby give a more long-term solution or long-term environment to the tree. The arbor raft, I think I've said its benefits in terms of creating aeration and irrigation space. Stormwater management is a critical element of urban tree management, and talking of utilizing infrastructure projects, I think we can see the problems that the water utility companies are currently having and the problems it's creating to our environment, and therefore anything we can do to manage stormwater, which appears to be the cause of much of these sewage dumping exercises, or claims to be, anything we can do to alleviate that is going to be to the benefit, and perhaps something that the water utility companies would be more than willing to engage in. Yeah, these things need to be considered by more than just the arborist or the architect that's designing the scheme. They need to be considered by all those that are going to be involved in the implementation of it and its function and then obviously the users as well, so that these initiatives can be bought into at the earliest possible stage. The flexibility of the Stockholm system, I think, has been well versed already. Its benefits: it provides that structural support using the aggregate to bind together and become load bearing, whilst providing some grow medium in between. Now, I suppose the downside is that the amount of space that's taken up by solid rock obviously reduces the amount of grow medium that you can have, and hence another reason for perhaps combining it with something like the crating system in larger projects. Okay, I think that's sort of outlined the main criteria. I thought if we've got time, we could have a quick look at a case study or two. This is a project, it's a private residence where where a swimming pool where the client wanted box head yew trees around the pool, and it's a fairly intensive construction with very little room for any soft landscape space that's in the wider garden, but around the tree we had to make provision for these trees, which are substantial trees. They're coming in at semi-mature specimen size and with root balls in excess of half a ton or a ton, and so we had to make significant provision for their establishment and long-term growth. The whole area will be sealed with paving at the end of it. So this, you can see again, we've used the crating system here, deep root silver cell, and you can see the extent of the cells that will be constructed beneath the paving. Quite important, because there's very little access to soft landscape area, it's quite important that everything the trees are going to need is provided in the cells, and the only reason we were happy that that was all they were going to have is that they are going to be maintained as topiary box head yews, and therefore the canopy will not ever be significantly larger than it is when they go in. Looking below ground, most important, I think, or one of the key areas that we focused on was ensuring sufficient irrigation, but also aeration. Sorry, I'm just going to see if I can get my pointer. There we go. So in addition to an aeration pipe and around the root ball itself, we've built in irrigation systems using 100 mil diameter perforated land drain pipes, and we've got 2 layers so that the soil at the lower levels is getting aeration as much as the soil at the upper levels. In terms of the mediums that we used to create the infill, we try and use soil on site wherever possible, because obviously it keeps costs down, but it also increases sustainability in terms of utilizing what's available to you. And we, in this case, we assessed the existing sub and topsoil, and some of it was suitable for recycling. We then mixed that with 50% sharp sand and biochar and 5% biochar. You see these soil mixes on here if you're interested. More the upper layer was imported topsoil to British standard and specifying the pH and fertility and soil structure that we wanted. And I think this is important that wherever possible, this needs to be part of the planting specification, so that we know what's below ground after it's all sealed over. We know that the tree's got what it needs to survive. Equally important is the drainage from the tree pit. So we're putting water in there, and drainage, stormwater will drain into these pits. But it's equally important that that there's an outlet for that, so that we don't get waterlogging or tree root death. The other medium that I didn't mention is that I said how heavy these roots are. I mean, the total weight of the trees is in the region of 1.5 tons when it goes into the pit. So the plinth on which it sits has got to be fairly substantial. And so we utilised the Stockholm principle here and put a mixture of large rocks into the pit and then washed in the subgrade, the local tree mix soil that we'd established. So soil mix 2 on this slide. So you can see a lot of infrastructure going in around it. There was the massive pipes and facilities needed to support the swimming pool and the sauna and the lighting and the even the AV that had to go in for around the pool. But yeah, it's a high-end job. So looking at it on the ground, you can see the silver cells there going in. You see that this one, sorry, let me just see if I can get that back up. You see here the tree pit area, that's the Stockholm soil has been added to the lower level, and it's supported by the net going around the outside of the tree pit. That net is then cut off at the level of the plinth so that the tree roots can ingress into the remaining cells. Someone was asking about the cost of a biochar I saw on the chat. That 1 ton bag there is about £2,000 worth of biochar. As it was a 5% mix, we're not putting much biochar in there, but so a little goes a long way. But yes, it is an expensive product, and there's a need to consider whether we have an enhanced biochar. The suggestion, I think, from recent research is that enhanced biochar with nutrients already added to it prevents the biochar leaching nutrients from the soil that you're mixing it with.
Sorry, just to interject, Martin. Jim, how are we doing for time?
I think, Martin, if you could just finish on this case study and then we'll move on. So
yeah, okay, sorry, yeah, I'll flick through. But the only other thing to mention here then is the aeration irrigation pipes that you can see there. And as I said, there was 2 layers of those. So case study 2, we're going to flip.
Martin, I'm afraid I'm going to have to ask you to
yeah,
conclude.
sure. I'll finish it there. So basically, in summary, we're looking at the need to embrace and promote innovation, education, collaboration, and integration in order to deliver maturity, sustainability, compatibility, and longevity of our urban treescape. And apologies for overrunning there. Thanks.
Okay, thanks very much, Mark. That's fascinating stuff. I'm particularly interested in to hear about your conceptualization of the 3 zones. So we'll perhaps talk more about that in the general discussion. Sue, are there any really quick urgent questions? Or should we
no,
move
there was nothing
on?
very urgent. I think we can move on. There's quite a lot which I think comes into the general discussion, which we'll
let's do that then. So it just remains me to ask our last speaker of the day, Steve Chapman-Grindy. Steve, if you could introduce yourself, that'd be great.
Sure. Let's get my screen working. Okay, can you see my screen okay?
Yes,
we can see that. Yeah.
Okay. So my name is Stephen Chapman-Grindy. I'm the General Manager of Deep Root UK, and my responsibilities also stretch into projects in Europe and the Middle East. And basically Deep Root manufacture a suspended pavement soil delivery system, which Martin has obviously just showed and demonstrated well. And I've personally worked for Deep Root for 17 years now. And during that time, we have worked on many diverse projects, installed thousands of trees in the system, all within the urban environment. We've successfully delivered many integrated tree and stormwater projects, but the project we are looking at today is a podium project behind the former headquarters of the Port of London Authority. This building was first opened in around 1922 at 10 Trinity Square. My first contact with this project was around May 2012, which is somewhat interesting to see that it was 5 years before the installation of the garden really started to take place. And I'm part of the project team with the architects at Wood Bagot, the consulting engineers at Bureau Happold, and Captain Simmons with the architects, which Sue James, who was one of the consultants on that team. Ardmore with a construction company, with the garden installation team being led by Frost Landscapes. Around this time in 2012, Sue and I met with Patrick Hegarty from the City of London Open Spaces Department to discuss this project, well, the project's potential really. So to give you a sense of where the project location is highlighted in the red box, this site is on Seething Lane and can be found just behind Tower Hill Tube Station, behind the Four Seasons Hotel on Trinity Square, and behind the London Bridge and Tower Bridge, really squeezed between the two of them. This is also the site of the diarist Samuel Pepys, who witnessed the Great Fire of London in this vicinity. So on the left, you can see the extent of the significant excavation for the basements and the underground car parking area. It's pretty wide open when we turned up the first time to have a look at this project. And on the right-hand image, the project has progressed with a concrete podium now in place, and it has been waterproofed at this stage. This is what we would start to build the garden on. When I was putting together these slides, I was also thinking it's quite unique for us to be building up from the garden from the ground upwards and not really digging down as we usually do when we install the silver cells. So one of the main project goals was to try and produce a healthy garden that would last well beyond 100 years. The build-up over the concrete raft consisted of a drainage board, stable sub-base layer, then the silver cells, and a 300mm aggregate and pavers layer on top. We needed to offer direct support to the granite blocks and footpaths. Supporting them with a silver cell offered a significant weight saving in comparison with the conventional support options, and it offers the ability for the trees to share the soil from the neighbouring planters. So these were the original drawings from Capita. You can see the podium plan in 3 sections. So the planting area is in white, the foundation area and conventional supported ground in red, and the paved areas, the granite blocks that required additional support to prevent the settlement, highlighted in blue. So for anyone who doesn't know what a silver cell is, it's basically just a modular suspended pavement system that uses soil volumes to support large tree growth and provide on-site stormwater management. It does this through absorption, evapotranspiration and interception. The silver cells are currently manufactured in 3 different locations here in the UK, Canada and the USA. They're an open structure. It's been designed this way really to accommodate unimpeded really larger root structures and deliver any type of soil. The round posts will simply deflect roots if they come into contact with it rather than trap them, and the system is not connected laterally, so they're an independent unit, independent stacks, and not directly relying on the cells next to them to gain strength or loading capacity. There was a lot of thought in the design and how best to deliver the soil in the system. They're pretty large unit really. I had trouble dragging them around the UK in the early years. They are 1200mm by 600mm with almost 350mm between post and post. So being independent also gives us lots of flexibility in field when we come across utilities and things in the ground that we didn't really expect them to be there. And in my experience, every city, every town we've installed this, we always come across utilities that were never really picked up by radars or pre-digging. So we delivered millions of cubic meters of soil and uncompacted soil into the silver cells over this time. Soil quality has been mentioned previously. It's vital to any project success, and soil is really a key component and should never really be overlooked. And Deep Roots have written a soil specification that we're happy to install in a single soil profile in our system. This specification basically narrows the parameters of the typical topsoil we have, the BS 3882 2015. It just narrows those parameters a little bit. And I'm often it's been mentioned again by previous presentations that I've often seen myself, that soil being stripped away on site and been taken away only to bring in a manufactured soil. And sometimes this is possibly not as good as what's just left the site. So a more sustainable option would always to be recommend first test the soil suitability on the site before we start taking it away and bringing in new soil. As you can imagine, this demonstrates, as you can see, this image demonstrates that the silver cells are mechanically loaded the soil into the system. We do ask the installers to walk around the soil as they load the soil into the system. And this is really the only compaction the soil needs. But this helps to also eliminate any large air pockets, and we deliver the volume that has actually been specified and limits any shifting of loose soil, which can cause significant soil settlement once water is introduced or moisture. And it's been shown to be good for plant establishment. We're not sweeping in sandy soils through small holes in the top, but we're delivering lightly compacted soils. On this project, because of the 2-meter height of the project, we actually utilised a 4X silver cell to bring us up closer to the street levels. The cell has a height of 1,441 millimeters, and it was achieved with our 2X system really. So we connected 2 of our longer posts together. They simply locked together to create that depth of post. So it brought us closer to the surface without having to use materials underneath really. So again, going back to the design, as part of Deep Roots' continued commitment and service to our clients, our technical team always provide project-specific cell drawings. So we actually lay the cells out so they can actually be part of the construction process. In this image, the pink hatched areas are the open planting areas, and each of the grey boxes represents a silver cell. So using them again to link the soil, allowing the trees to access soil across the site. We do not place cells under the lawn on the left-hand side, as this did not really need any structural support of the cells itself. So this is the start of the cells being laid out, and this was around February 2017. It's quite easy to see that the build-up required to reach the street level, like I said, almost 2 meters. And the soil volume being provided in the cells was around 500 cubes. So first, the screeded layer was placed over the drainage board, the void former of that. And this would be the base, the solid base that the silver cells would then be placed on. So these are the first silver cell 4X being installed that would eventually support the pagoda, the area just before the lawn. And we used a sandier soil than we've normally used because of the overall soil depth on this project. This was really to aid drainage, prevent the soil becoming anaerobic by the compacting of the soil under its own weight. So the general rule of thumb, we do not need to place a structural soil in the silver cells because the silver cell itself is the structure. It's providing that load-bearing structure. So that's why the soil remains uncompacted within the system. This way we deliver, soil with as much smaller footprint, say, than a structural soil would need to give the same net gain for the trees. So this is by July 2017. A total of 1,300 cubic meters of soil was actually used across the site. And you can see the planting areas and footpaths really taking shape. So just a reminder of if you strip away the hard landscaped areas, you would see the structural cells supporting the pavement in the granite blocks. And we basically placed that on this side up to and on the inside of the granite blocks. So they were supported directly on top of the silver cell to prevent them granite blocks settling in any way. So some 14 trees were planted and around 3,000 shrubs were planted in total. And this obviously will all improve the biodiversity of the area and have become an important habitat for some of the wildlife in the city. So 2017 to 2019, so a couple of years, and this shows some promising establishment for the growth in the first couple of years of this project. And because the silver cells are supporting the paving, the granite blocks, it was important that they have the compressive strength. With this paving profile, they're able to comfortably take a load of 11,000 kilograms on a surface area of only 200 millimeters by 200 millimeters, or put that in some more context, 23,000 kilograms per axle. So more than twice the limit of an articulated vehicle. So we have no concerns or little concerns about articulated vehicles popping up on this curbside or anything over the top of the cells. More than happy that they can sustain that traffic weight. So one of the most important aspects, I suppose, of any successful project, especially for deep root, is really supporting the infrastructure. And I know we're really judged on the success of the trees, which is really understandable because that's what we're providing as the product really serves. But we also need to be sure that there's no settlement in the paved areas, because that is a failure for the product if that was ever showing. So sustainability was always in the forefront of this design team. The project is actually taking water from the roof of the building, which is then filtered down into the basement before being reused to irrigate the gardens. Taking some of the water offline during the every rain event is also adding capacity to the already overburdened sewerage system. And this is something we've replicated on much larger scale in projects in Liverpool recently. So we've not been actually monitoring this project in terms of tree growth, but you can definitely see the significant growth rates in healthy trees in this short time from 2018 to 2023 here. It's sometimes disturbing how often we see nil and negative tree growth across the UK. And if we talk about value, there's little value, both monetary or environmental terms, if the trees are being replaced every few years, or if the canopies are never large enough to actually contribute to the full environmental benefits that we know that are out there and trees provide. And on that, most research is actually based on large canopy trees. So we need to be able to get our urban trees large enough to actually contribute. And we all know how increasingly important it is to create a green oasis or pocket parks in our cities and towns, especially offering shade, as apparent now in Europe. And this project created a green open space that is really filled with office workers during almost all lunch breaks. So up to the present day, from 2022 to 23, this project is wheelchair accessible. It's very welcoming space for everybody in the city centre 24/7. This project is not like any other. I understand there's lots of moving parts to make a project like this work. And I've been involved in many regeneration projects where even the local community sometimes see little value in what we're doing. And I've even seen oranges thrown at the workers in Northumberland, for instance, only to have the community's perception changed when sometimes you go back a few years later. So, it is important sometimes to have a champion to push these projects through, but the project still has to add value in the end. So the vision at the start of this was to really achieve a 100-year plus podium garden. And with the right design, collaboration, workmanship, products, and commitment, this can be achieved. And almost 17 years on, when I first started working for Deep Root, I spent my time really mainly talking to councils about the important correlation between soil volume, soil type, and the ultimate size of tree. And I think we've come a long way since them days, but still, there's a lot of work to be done regarding things like maybe having a robust BS soil specification for trees, or a minimum soil volume target in the UK. But, with the more successful urban projects where trees are performing to their natural optimum growth rates and not stunted in small volumes, we can show the real benefit of designing outside the usual parameters. Without factoring in climate change, whether these trees at Trinity, or the 40+ trees we recently planted at Wembley from the station to the stadium. You know, a project with underperforming trees is not good value for money on any project. And like this, if it can last for 100+ years, surely that's good value for money. So thank you all for your time. I hope you get a chance to take lunch in this green space on a sunny day, like I have so many times. It's a really nice project to walk along and visit sometime.
Well, thank you very much, Steve. That was excellent, and it really gives you a sense of what can be achieved when everyone collaborates and puts their mind to something, and also you have the resources to deliver that. So that's great. So thank you again. Sue, are there any urgent, we've got a little bit of time in hand. Are there any urgent questions for Steve, or should we go straight into the general discussion?
No, I think Steve has sort of silenced everybody by the comprehensive nature of what he actually showed us, but it just shows what actually can be done.
Yeah, okay, well, that's great. All right, thanks. So what I'm going to do now is just quickly recap some of the main points of each of our speakers. And then I noticed, Sue, in the chat there was a question about utilities, but I'll deal with that at the end, if you could remind me what was asked.
Yeah.
But what I'm going to do is quickly recap Hen's talk was really about, she was highlighting the issues about species selection, the need for cooperation, professionals between professionals, and also that highway officers and tree officers do need to cooperate in terms of giving each other advice about what's required and understanding each other's objectives in terms of the work that they're dealing with. And that's highlighted, as I mentioned earlier at the very beginning, by the NPPF paragraph 131, getting that cooperation embedded into developments. And it's also, if any of you are familiar with the Sheffield Street Tree Inquiry report, mentions there that highway officers need to liaise more closely with tree officers, tree specialists in the future. So that's good. Bjorn's talk was fascinating, and I pulled out from his talk was that what you need to do is to create those simple plant bed constructions that provide all the physiological needs of the tree, in terms of putting crushed stone in there when you mix it with a good substrate, a good planting medium. But also what I found very interesting on Bjorn's side was making sure that the execution of that construction was properly supervised, and making sure that control by the commissioning authority is there when it's being built, because that gives you the confidence that it will actually deliver what you want. Martin also went into some detail on replicating soft landscape, the soft landscape that trees evolved in the urban realm, so making sure that you have the growing medium. But he went further than this and said that he conceptualized the 3 zones around newly planted trees, one for the actual tree aperture or the tree pit itself, another slightly larger establishment zone, and then something a maturity zone. And he also mentioned that these are not regular shapes. These can come in all, you know, when you're planting trees, you can look at what's around you, and you can achieve those zones in irregular polygon shapes if you need to, not just squares or circles. Also, Martin looked at the culture, changing cultural thinking to proactively prioritize integrating tree roots in the underground environment. And Steve, we've just heard from Steve, mentioned about the reuse, if possible, the reuse of soil on site, if it's suitable, rather than bussing in soil or lorry driving soil in itself. And also the silver cells, because of the way they're constructed and the load bearing capacity, they permit lightly compacted soils, which are designed to cope with the lightly compacted soils which is better for tree growth, tree and plant growth, but also that those silver cells are designed to cope with the accidental vehicle use. So you mentioned about axle weights being those structures beneath the ground being able to cope with them, and redirecting drained water at the bottom of the construction back into the irrigation system, which I think was a really good point. So that's it. So I think we're going to throw the floor open to questions now.
Okay, so 2 things. If anybody's got a question, just turn your camera on and put your hand up. And Martin, Bjorn, Steve, Hen, if you put your cameras on, people can see you. One thing that came up from Matt Conlon Perry, I think quite a lot of people are concerned with the cells because they're plastic, even if they're recycled plastic. He asked if any research has been done on long-term biodegradable inert support systems.
I can
And
jump
in which situations would those actually work? Let's think about it, because obviously sometimes they wouldn't. Steve.
You know, I can understand everyone's concern about plastic because it's a very topical subject over the last few years. You know, this is a load-bearing product, and I think as much as we would like to be, you know, even our product is only up to 77% recyclable material. We'd love to be able to get it to 100%, but that takes a long time and a lot of dedication to try and get those products up to those, and you know, maybe even reducing the amount of plastic, which is why we redesigned the silver cell from silver cell 1 to 2, so we could actually reduce the amount of plastic being manufactured in that process. But I think that the integral part of all this is that this is a loaded product. We are putting it onto car parks, we're having traffic driving across it. Any change that we make in terms of material or the structure of the plastic we're manufacturing has to be certain it's going to stand up to that load-bearing factor, but also for a long term. And that's where the industry struggles a little bit. I mean, of course, we'd also like to be manufacturing out of something that is, you know, more sustainable at this moment, but I think we're just not there yet. And the plastics industry in general, I mean, you know, there's more plastic being used for more harmful structures in our everyday life, whether that's the automobile industry, there's plastics going in, conduits, everything else. So it's difficult to also firmly focus on our industry, I think, when actually we're trying to produce something of a carbon scrubber out of our system. So to try and benefit by using this product, and we're burying that carbon in the ground. But it is recyclable. We're trying to get there as a company to be more sustainable, but we also have to bear in mind that load-bearing factor is really important for our product.
And also, it's presumably you've got some confidence with the 100-year garden that the cells have a 100-year life alongside it.
Yeah, I mean, we go through a stringent process of when we manufacture, we keep it out of sunlight. You know, it does degrade under sunlight, so we keep it out of there. And once you put it in the ground, it's inert, so it never actually reaches that to actually degrade as the product. So yes, we're more than confident that's going to last 100 years plus in that garden.
There was one question about biochar. Sort of people are concerned, does the carbon footprint of creating biochar outweigh the benefits of having biochar? But Bjorn, your biochar is a circular process, isn't it?
Yeah, that's why we call it biochar. I mean, biochar is made out of a waste material, and it's made in a way that is sustainable, and you have to take care of all the energy you get, so that you don't get energy losses. And in Stockholm, we have are fortunate to have this district heating system. So anyone who is producing heat can connect to this heating system and produce heat. And that's what you get from when you make biochar. The byproduct is heat, and it's almost no emotions let out from the process. So we get biochar and we get heat. And the company that sells the district heat sells it as sustainable heat for their customers. So the customers pay more for that kind of heating system than the other ones that made from garbage or oil or anything else. So that's the whole thing about biochar. It's made from waste in a sustainable way. So a lot of cities around in Sweden are building their own biochar facilities to recycle their garden waste in the cities and use it for planting trees. It's all over Sweden now, and it's not just Stockholm that's building this kind of structural soils in Sweden. It's all the big cities are doing it in some way or similar to Stockholm, and all of them are using biochar in it because it's we don't want to use peat moss, so we don't want to use natural sand and everything. Of course, we try to use existing soil if it's there, but mostly it's not, especially not in new development areas and so on. And one thing about the structured soil, I mean, it can take loads, and it has structure from the beginning. industrial made soils are dead. Our soil is also almost dead from the beginning, but we have structure in it from the beginning. If you have these small stones 2 to 6 millimeters with biochar and compost, so compost you could have, if it's normal compost, there are living organisms is in it. And and it can take loads. So you don't have to be concerned if the entrepreneurs are moving with heavy trucks or machines on top of this mixture, because they can't destroy the structure. And this is so simple. It's just copying nature. It's nothing else. It's where all the woods around the world are living in. And if you have this selected stone material, you get a load bearing capacity of it. So you don't have to think about it. So my dream is, of course, when you build a new city in the world, make it with the open stone material. Then you can just cut open a square on the hard surface and plant a tree, put in some extra compost and biochar there. It's so fantastic.
We'll have to get our district heating going here so that we can be
yeah,
totally
but
circular.
you can make oil, and you can make a lot of other things from the byproduct. It depends on how you make it, and then you can take it out as oil or heat or anything else.
Jim, I think we have to tackle this utilities question. So Simon Rowlinson said that we haven't really touched on the issue of utilities, and particularly in dense urban environments. This can be a sort of potential barrier to tree planting.
Yeah.
But
yeah,
things are moving.
I've got a couple of questions before I answer that directly in terms of that question and today's subject. I'd just like a question for Steve and for Martin, actually, and also Bjorn, if he has experience of this. So we'll go with Steve first. Obviously, the examples that you gave, there were no utilities in the underground garden, but when you're putting in these silver cells, have you experienced any follow-up conflicts or disturbances from utilities needing to gain access to that, to stuff that you've integrated into them? And how has that worked, and what do you do to address those issues?
Yeah, I think probably had a utility conflict in every single silver cell we've installed in the cities, from north, south, east, and west. I think it's a common factor, that we're entering into a zone where we live in old cities and towns. I mean, new developments are great because you can run chases down the side, you can accommodate them. But even in one project, I can think straight away comes to mind in Leeds city centre, we're going to plant 140 trees. I got a call on the first day saying, Steve, I don't think we get any trees in here. And we went to site, and there's just a myriad of utilities everywhere. It's really about the utility companies and their willingness, or the council's willingness, to work with us. I mean, we have a product that's designed and it's not connected laterally, so you can rotate the cells, you can step up, you can step down, you can put utilities above it, you can put them underneath it, you can run them straight through. It just depends on the will of the utility company to work with us, really. And that's really the end of it. I mean, like I say, I can show you a million images of projects we turn up to where everyone thinks you can't get a cell in, and we walk away with 20 cube for a tree. So we can do so much, but there's got to be some flexibility in the people we work with, and mostly the utility companies. I mean, a lot of the time we can even, electrical cables, things that are really simple, you can put them over the cell system in the aggregate layer below the paving. But water, gas, and things like that, then we try to, as much as we can, run it through the system. Now, in places like Toronto, for instance, in Canada, the council and authority allow utilities to run straight through the silver cells. And so they have a maintenance program to go back. If they ever have to go to a water or a burst pipe, they have a whole maintenance program to do that. Now, the reason they use the silver cells is because they are not connected laterally, and it allows them to go in there with a digger or anything else to rip out the cells, basically, go down, mend the pipe, put either a lean fill in if it's winter time, and then come back in the summer and put the cells back and reinstate the cells. They're only concerned that it's not pulling on cells next to it, so you don't damage the integrity of the other areas. But there's whole maintenance programs to go through that. But yeah, I mean, it's what we've had to deal with since the start of installing the silver cells.
Okay, that's really interesting, Steve, and I think it mirrors my experience. Because when we were developing there's a motorbike outside my house. I don't know if you heard that, but we were developing the original guidance, the NJUG 10 guidance, and the subsequent guidance, which is now Streetworks UK Volume 4, utilities were very, very precious about what could and couldn't happen around their apparatus. But the reality, and I think this is what the message in answer to, is it Simon Rollinson who asked the question? So yeah, in answer to Simon's question, utility companies have no legal status to prevent you planting trees if the landowner agrees that you can do that. The legal status they have is if there is a problem subsequently, they can come in and remove the tree and repairs, as Steve has just highlighted in terms of the silver cell use. They've got powers to go in and rectify a problem, but they can't prevent you planting a tree in the first place immediately adjacent to their service. And when we were producing the guidance, they tried to embed that in the guidance as being, indeed, one well-known arboricultural consultant who I won't mention said that they could work a mathematical formula to calculate it, so it would be all fine and dandy. It just wasn't possible. So what we're left with is that if the landowner, local authorities, agree, you can plant trees immediately adjacent to all the different utilities, but you're just accepting that if there's a problem going down the line in the future, that you may need to lose that tree, and they have powers to do that. And I think the main thing to take away from that is that going forward, modern utilities, particularly in modern plastic ducting, they can accommodate the presence of trees and tree roots. And that's why I mentioned that in my introduction that we should now be considering tree roots to be the fifth utility. And there isn't anything in legal. I mean, I had one example, I can't mention it, who it was, but one example, there was an operator wanting to plant some trees near a utility, and they were asking the utility to sign, the utilities were asking the tree planting organization to sign an insurance indemnity waiver. You know, there's no legal status for that at all. They don't need to do that. If you've got the landowner's permission, you can plant the tree right next door to that utility, and it's at their own risk, the utility's own risk. If it causes problems, they can come in and mend it and repair it, and the tree may have to be removed, but that's all it is. So I think that's the legal situation. Sue, come in.
Can I just ask, so there's been a bit of stuff in the chat between Andy Tippin and people about utility companies charge a fortune to redirect utilities, which I think we all understand. But what we're trying to say here is that we can actually find ways to accommodate tree roots without automatically assuming that the utilities have to redirect, which could be too expensive for the company.
I'd be interested to hear what Bjorn does in Sweden with that sort of similar problem. So, Bjorn, if you could come in.
Okay. We just leave them there if it's okay, and if it's possible, we just push them on the side, because we always, when we remake a sidewalk and plant trees in it, and it hasn't been trees there before, we push all the utilities to one side, close to the building, and then we concentrate the structural soil in the open area. But there is every 5 or every 10 meters some crossing pipes or line electrical cables, and they're just inside this structure. I mean, we just pour out the stones and compact it around, and sometimes if the owners of the pipes or the electric cables and things are a bit worried, we put finer materials just around it, and some textile fabric or something if they want to, but most and less it happens, because they have accepted it and understand what we're using. The material is similar to what we're using before. It's just not the fine material that's there anymore. It's just bigger stones. So it hasn't been any problem, but they were scared in the beginning.
Yeah, I think that's my experience. I think we're at a tipping point in this country. It sounds like Canada and other countries have already reached that tipping point where they're now seeing trees to be essential critical infrastructure. And what I'm interested in is that we're now getting good discussions going within government departments about how to achieve this. And it's important that we keep up the pressure to make sure that those utility companies acknowledge that they're not the only games in town, and we need to provide trees for our urban centres. So, Martin, have you got anything to add to that, or Hen?
Yeah, I mean, I think it does come back a bit to what we said previously, that you know, this need for a step change in the way we build the urban realm. The fact that that's how it's always been doesn't make it right, and saying that we can't do anything about it is a very negative approach. I think, as you say, it has to come from government, or it has to come from planning law. And I think obviously the starting point is new build. There's so much opportunity there to get it right in the way we design the subterranean landscape. And if we can have service trenches, shared service trenches that accommodate most of these services, and then use the other space for the tree roots. I mean, I think sort of specifying it, making sure that, because utilities are an afterthought when it comes to building housing estates and everything, and that's just not acceptable. It has to be part of the design. You know, it's like, say, building a house without designing the roof structure or something. It's just not realistic for longevity. So in terms of existing services and retrofitting, I think again the tree pit design has to, or the growing environment design has to incorporate these services, and where you, as you said, where they can duct them through the cells or through whatever structure it is we're putting in, so that there's access at either end of the tree rooting environment area so that the services can be maintained and pulled through without digging up the structure that's been put in. Yeah. I mean, it's as frustrating, I think, for those people that have designed the surfacing to have it trenched and tarmacked over rather than.
Yeah, that brings, I think that nicely segues in. Hen, have you got anything to add to that as a local highway authority? I mean, the issues between street works and utilities is a long-standing problem, isn't it? So
it's a massive problem, and if anybody's ever struck a fibre optic cable, you know how expensive a massive problem it is. And I mean, local authorities do tend to be somewhat risk averse, because getting it wrong costs a lot of money that we haven't got. So we do tend to, I mean, I think it was Martin that just said about just because we've always done it that way doesn't mean it's the right way, and I totally agree. But it does mean it's the cheapest way, because so the risks, and we can work with the risks. It's not a way forward for the future. I totally agree. But that's kind of from the local authorities' point of view. If we did something, if we sort of like as a landowner, as you say, agreed a tree to go in that damaged a fibre optic cable, we would be liable for that. That's millions. We just can't take that risk for a tree.
Yeah, Martin, you got
Sorry,
your hand
Martin.
up.
I think yeah.
No, just to add that, you know, the other thing for when these utilities are going in, surely there should be underground mapping, so that we know what's where, because we don't know where these services are, and that's half the problem. And especially,
well, I think you hit the nail on the head there. I don't think they know where they are half the time. So, and Sue and I were at a meeting the other day, a London Urban FRAC meeting, where the GLA are looking at doing some digital mapping of these services in London. I applaud that. I think it's good, but you've got to base it on real data, because a lot of the old maps that these utility companies have are out of date. So I think going forward on new developments, it's, you know, we know what we need to be doing, but what I was worried about was losing ground to utilities saying, oh, you can't plant here because the digital map says so, sort of thing, when in actual fact what you should be doing is, as Steve mentioned, dig a hole and find out what's there, you know, sort of thing. So yeah.
Jim, I've got one last question for us probably to end on.
Yeah.
$64,000 question. Does Jim have any idea how soon the supplementary technical guidance for highway tree management and the new DFT manual for streets will be published?
Right, I knew I was going to get that question. I'm afraid I can't be specific on that, because we are waiting on seeing what manual for streets itself says. I know last time I spoke at one of these meetings, I said it would be towards the end of the year, but I'm afraid I can't be more specific. As soon as I know, I'll let Sue know, and we can take it from there. But apologies for that.
Okay, well, I'll save the chat and send that round.
So I think we're wrapping up now, Sue. Are we almost close to time? Yeah,
I think we're quite close to time.
I'd like to give our speakers one more final opportunity to say something if they want to. So I'm going to go around quickly in order of they are on my screen. So Martin, anything to add quickly?
Nothing profound, I don't think, but obviously that it's critical that we design these from the earliest possible concept stage rather than coming in as an afterthought.
Right.
That's the main frustration from my end, I think. Great,
thank you, Martin. Bjorn, anything to add quickly?
Yes, that copy nature know how to make it, and we just copy what they're doing, and it's easy.
Okay, thank you. Hen, anything to add quickly?
Quickly, yeah, there was a question very early on which I didn't get a chance to answer. Somebody asking about why landscape architects weren't giving us the information we needed, the right species, and it's a question that I would love an answer to myself. So if there's any landscape architects out there on TDAG, then could you please have a look at that question and come up with some answers to it?
Great. Okay, we'll follow that up. Okay, and Steve, you get the last word. So anything to add quickly?
I suppose it's not being negative or anything, but I would urge anyone to look at Nainis Basic's Cornell University structural soil studies in the past. I think growth rates are really important. So I'd be interested to know from Bjorn what his growth rates are in that product compared with just growing a tree in soil. In my experience, trees perform better in soil.
Okay, thank you very much. Right, and so I think we're up to close to time. Sue or Emma, do you want to add anything or have the last wrapping up word?
Well, as a child, I used to be known as Emma Last Word, so I'm just going to dive straight in. Well, I won't be the last. Sue might have something to say, but I would just like to thank all of our speakers and all of the audience for coming along today, and also point out that the next TDAG seminar will be on Wednesday, the 20th of September. The link is in the chat, and it's on carbon. I forget exactly what, now I've pasted it. Sue, anything to add?
No, I'm just busy trying to make sure I've saved the chat, which I've done, right, so that's good. There's quite a lot of things in there to which we are, as Trees Design Action Group, desperately working to sort of address, so keep an eye out what we're doing. Emma and I sort of sort out a program for the whole year, so if anybody on these talks has anything they feel are urgent and should be included in those discussions for 2024, please let us know, and also particularly if you'd actually like to speak at one of them.
Lovely. Okay, thank you very much, everyone. Coming up to time. I think that's it then. So we shall all say goodbye.
And thank you, Jim, for chairing so well.
My pleasure.
Thank you to all the speakers.
Bye-bye.
Bye, everybody.
Thanks very much.
Bye.